We are going to look at the different types of cross-site scripting today. For anyone watching, if you want to learn the basics of cross-site scripting, please watch my previous video by clicking on the link above. The link is also left in the description of this video. Okay, let's get into the different types of cross-site scripting. At a broader level, there are three different types of cross-site scripting, and these are reflected cross-site scripting, stored cross-site scripting, and DOM-based cross-site scripting. Reflected cross-site scripting attacks are the most common type of cross-site scripting attacks. This type of attack is also called non-persistent XSS attacks since the malicious script supplied as input is not stored anywhere. The scripts just hit the web server and come back. In a typical attack scenario, the attacker injects malicious scripts into any of the input fields or parameters, and the application accepts the malicious input and transfers it to the server via a HTTP request. In response to the HTTP request, the web server returns a HTTP response. The web browser receives the response from the server and interprets the response, considering it to be a trusted response from the server. This results in execution of the malicious script. The events that occur in a successful reflected XSS exploit is as you see in the screen. The user logs into the application and sends a reliable HTTP request to the server. The attacker catches the request, crafts a malicious request by injecting scripts by altering any of the input parameter. Attacker forwards the request to the web server and the server sends a HTTP response for the malicious request that was originally sent by the attacker. The injected script gets executed in the user's browser. Sensitive information is returned to the attacker via execution of the injected script. Let's look at stored cross-site scripting next. Stored cross-site scripting is also called persistent cross-site scripting. In a stored cross-site scripting attack, the malicious script supplied by the attacker is stored either on the web server or in the database. The script is then executed on a later stage when the user requests for another web page that fetches data from the database or the web server. Unlike reflected XSS, stored XSS might affect more than one valid user if the malicious script injected is stored in a common database table and is requested by multiple users of the application. Now, moving on to DOM-based XSS. Now, in the previous session, I mentioned unlike injection attacks for cross-site scripting to work, the malicious scripts should return to where it originated from. In our case, it is a web server after it is being accessed or processed on the server side. While this is true for stored and reflected XSS, DOM-based XSS is an exception. This type of XSS is also called client-side scripting attack because the injected scripts do not reach the web server at all. Let's understand what DOM XSS is all about. Web applications sometimes use client-side JavaScript functions for various reasons. For example, for validating user inputs before the request reaches the server, for performance reasons, or for reducing processing overhead. If a client-side JavaScript function fails, the HTTP request will not be sent to the server and an error message is immediately thrown to the end user. So the process looks like this. The application sends a HTTP request with values in its input fields. Then the request is caught by a client-side function and is validated. If an error is found, the request is not sent to the web server at all, rather is returned to the user. So if the request is valid without errors, it is sent to the web server for processing. A loophole in the client-side JavaScript function can be utilized by the attacker to exploit a DOM-based XSS attack. This attack is thus said to play around the document object model of the web browser. For example, the HTML tag that you see in the screen is used for accepting username from the end user. Input type is equal to text, name of the field is username, and the value is going to be a value that is applied by the end user. So if a client-side validation function similar to the one you see in the screen checks for malicious characters in the input and displays back an error message along with the user supply data, the page is said to be vulnerable to XSS attack. So you see the client-side validation function, but it also has a document.write statement that says a generic error message which is all about saying special characters are not allowed on input fields, but it also returns the input which is originally supplied by the end user. So in the case of a script being supplied as input, the same script will be written using the document, the dot write statement, which causes the execution of a malicious script. So if the malicious user supplied script as input, and since the validation function writes back the input, the script gets executed on the web browser. Note that the request is not being sent to the server, and thus it is differentiated from a reflected cross-site scripting attack. The next session will be hands-on with demonstrations for the different types of XSS. I also plan to demonstrate the real-time cross-site scripting scenario. Keep watching, like, share, and subscribe if these sessions are helpful to you.